Hello, welcome to Unit 6, Lesson 1. I'm Professor Blackman. In this lesson, we're going to be talking about radical expressions. So we're going to be looking at square roots, cube roots, we're going to be looking at the domains of square roots and simplifying all different types of radical expressions. So the symbol that we will use for roots is like this. Some people call them roots, some people call them radicals. Underneath, right here, underneath it is the radicand. Just so you know the vocabulary terms. All right, let's go ahead and start looking at some examples. Okay, so the square root of 25, we have the rule up here that says the c is the square root if c squared equals a. So square root of 25 is 5 because 5 squared equals 25. All right, so the square root of 4/9, well, that will equal 2/3 because 2 times 2 is 4 and 3 times 3 is 9. All right, so this is a -7/6. So we're keep that negative out in front, so that'd be a -7/6. And this is -225, so this is not a real number because you cannot find two numbers that multiply that give you a negative number, at least not a real number. All right, let's look at some more. All right, so in these, we're going to find the outputs. So we're going to plug in 5 times 6 minus 10. 5 times 6 is 30. So 30 minus 10, which is the square root of 20, which we put that in our calculator is approximately 4.5. All right, let's plug in 2. So 5 times 2 minus 10. 5 times 2 is 10. 10 minus 10 gives square root of 0, which is 0. If we put in 1, 5 times 1 minus 10 gives us 5 minus 10, which is -5, which the square root of a negative number is not a real number. And if we put in -1, 5 times -1 minus 10 gives us -5 minus 10, -15. So same thing, square root of a negative number is not a real number. All right, so the domain, so if you see none of these here, the last two gave us values of x that fit in our domain. And so our lowest value is 2. So whenever we have a square root, what we do is we take the radicand and we set it to greater than or equal to 0. So this would be 5x greater than or equal to 10. X is greater than or equal to 2. So if you notice, all the ones that are 2 or higher had values. So the domain of f of x would be x is greater than or equal to 2. All right, let's look at another one. We're going to plug in 4. So we got negative square root of 2 times 4 plus 1. So that's negative 2 times 4 is 8 plus 1 would give you 9. So that is a -3. Plug in 0. That's 0 plus 1. So that is the negative square root of 1, which is -1. Plug in -1. And we get -2 times -1 plus 1. So that's -2 times -1 is -2 plus 1 gives you -1. So this is not a real number, not a real number. And plug in -1/2. So 2 times negative 1/2 plus 1 is negative. Half of 2 is 1, so negative 1 plus 1, which would give you 0. So this equals 0. So again, when we're finding the domain of a square root, we take the radicand and we set it to greater than or equal to 0. So then we get 2x greater than or equal to negative 1, and x is greater than or equal to negative 1/2, which, as you see, negative 1/2 gave us the 0 here. So our domain is x needs to be greater than or equal to negative 1/2. All right, let's look at some more examples. All right, so the square root of 16 is 4, and the square root of x squared is x, but we need to make sure that x stays positive, so we put it inside absolute value bars. So we have 4 absolute value of x. That 4 could be inside or outside. Mathematically, it's the same. All right, so here, if we square a square root, we get 144c squared, which then would become 12 absolute value of c. Don't read that as 121c1. That's absolute value bars, the absolute value bars of a variable. So when we have absolute value, this always generates a positive result. Because we can't say it's 12c and we say it's 2, that's fine. But if we say it's a negative 2, then we run into issues. All right, let's look at some more examples. All right, so cube roots. So we need to find a number that is cubed that gives us 216, and that is 6. 6 times 6 times 6 gives us 216. This is a negative 125, so this is a negative 5. And unlike square roots, with odd roots, it's fine to have negatives because a negative times a negative times a negative is a negative. And then y to the third is a y. All right, let's look at more examples. All right, so now we're going to do outputs. So this would be the cube root of 7 plus 1, which is cube root of 8, which we do know is 2. All right, so we have 26, so plug that in, 26 plus 1, which is the cube root of 27, which the cube root of 27 is 3. All right, now we're going to plug in a negative 9. Negative 9 plus 1 gives us the cube root of negative 8, which is negative 2. Cube root of negative 65 plus 1 gives us the cube root of negative 64, which is negative 4. All right. Over here, we have negative cube root of 2 times negative 62 minus 1, which is the negative cube root of negative 62 and 2 give us a negative 124 minus 1 is a negative 125, which is negative 5, which is positive 5. When we plug in 0, we get 0 minus 1, which is the cube root. Don't forget about your sign of negative 1. So that's a negative 1, which is a positive 1. Cube root of 2 times negative 13 minus 1, which is the negative cube root of negative 26 minus 1 would give us negative 27. So that is a negative 3, which is a positive 3. And then 63, plug that in. That's 2 times 63 minus 1. So negative cube root 2 times 63 is 126, minus 1 is 125. And so that equals a negative 5. So this is how we plug in. It's very similar to function notation, which we've done in the past. Let's look at our last set of examples. All right, so we need to simplify with different roots. There's this rule right here that makes roots a lot more useful, that if you have something raised to the power of k, then that root cancels out that power and you just get a. So this can be written as negative 1 to the 5th. And since this root and this power are the same, this gives us negative 1. So this is negative 4, and this would be a 4 here. And that is 5 to the 4th power. And so that 4th and that 4th gives us a 5. And then we need to figure out what 256 is. And that is 4 times 4 times 4 times 4. So that's 4 to the 4th. And so that's a negative. That root and power cancel each other out, give us a negative 4. That negative is being pulled down from the front. So with this one, we're going to rewrite it, trying to write it in the power of 5. So that is a negative 1 over 2 to the 5th power. And that power and the root cancel each other out, giving you negative 1/2. That's all I have for you today. Happy studying.